September 4, 1943. River Rouge Complex, Dearborn, Michigan. Two German intelligence officers stood beside an American guide, watching B-24 Liberator fuselage sections roll past on assembly lines that stretched beyond visible horizons. The noise, pneumatic riveters, conveyor systems, 20,000 workers performing synchronized tasks created an industrial symphony no European factory could match. Their notebooks filled with figures, production rates, workforce size, machine tool capacity, material throughput. But the numbers seemed impossible. Each man had studied American manufacturing capability for years, had briefed Wehrmacht commanders on American industrial limitations, had assured Berlin that mass production of complex aircraft remained beyond American engineering discipline. Standing in Ford's bomber plant, watching one complete fuselage emerge every 18 minutes, they understood their assessments had been catastrophically wrong. The war's outcome, they realized in that moment, would not be decided on battlefields, but in facilities like this, and Germany possessed nothing comparable. The invitation had arrived through official diplomatic channels in late August 1943. The United States government, confident in its industrial strength and eager to demonstrate Allied capabilities, offered Axis attachés and intelligence observers tours of selected American war production facilities. The gesture seemed puzzling to German intelligence officers in Washington. Why would the enemy reveal their manufacturing capacity? But the Reich Foreign Office authorized the mission. Two men received orders. Captain Fritz Wiedemann, a military attaché with extensive industrial experience, and Dr. Gustav Stolper, an economic analyst specializing in American manufacturing. Their assignment was straightforward: assess actual U.S. war production capability and report whether American claims of overwhelming industrial superiority matched reality. Both men expected to find propaganda and exaggeration. American factories certainly produced impressive consumer goods, but complex military equipment required precision engineering, skilled craftsmen, and manufacturing discipline that Germany's centuries-old industrial tradition had perfected. The Ford Motor Company's bomber plant at Willow Run would provide their first test case. The journey to Michigan began September 3, 1943, when Wiedemann and Stolper boarded a military transport aircraft at Washington National Airport. They carried notebooks, technical reference materials, and specific questions about American manufacturing methods. German intelligence had provided detailed briefings on what to observe: workforce skill levels, machine tool precision, material handling efficiency, quality control procedures, and most critically, actual production rates versus propaganda claims. Their instructions emphasized skepticism. American industrial statistics had proven unreliable during the Great War, and no reason existed to trust them now. The flight took 7 hours, with one refueling stop in Pennsylvania. Below them stretched the American heartland: endless farms, small industrial cities, railroad networks connecting every settlement. Stolper noted the observation in his journal. Transportation infrastructure appears comprehensive, no visible war damage, civilian population seemingly unaffected by conflict. These details mattered. Germany's war production operated amid constant Allied bombing, transportation disruptions, and civilian deprivation. America's factories functioned without such constraints. Arrival at Willow Run on September 4 provided immediate shock. The facility's scale defied European manufacturing experience. The main assembly building stretched 3,200 feet long and covered 67 acres under a single roof large enough, their guide explained proudly, to accommodate the entire Axis battleship Tirpitz with room to spare. The building contained no interior support columns, just vast open spaces filled with assembly lines, storage areas, and precisely positioned workstations. Wiedemann's first notebook entry simply stated, "Dimensions exceed any German aircraft production facility by factor of 10. The guide, a civilian engineer named Robert Thompson, provided an overview as they walked from the entrance. Ford had purchased 975 acres of farmland 2 years earlier, and transformed it into the world's largest aircraft manufacturing complex. Construction had required 42 million cubic feet of earth excavation, 3,500 concrete pilings, and over 80,000 tons of structural steel. The plant employed 42,000 workers operating across 3 shifts, 7 days per week. Monthly production currently stood at 450 B-24 Liberator bombers, 14 per day, 1 every 63 minutes. Stolper requested clarification on the production figure. 14 complete 4-engine heavy bombers daily seemed mathematically impossible. He had studied German aircraft manufacturing extensively. The entire Reich aviation industry produced approximately 1,000 aircraft monthly across all types and manufacturers. This single American factory claimed output approaching half that total for one of the war's most complex aircraft. Thompson confirmed the numbers and offered to demonstrate. The tour would follow a single bomber from raw materials to flight testing, tracking every manufacturing stage. The proof would be visible and undeniable. Their first stop was the wing assembly section, where the B-24's distinctive Davis high aspect ratio wing took shape. The Davis wing, designed for long-range efficiency, required precision manufacture structural spars, control surfaces, fuel tanks, and hydraulic systems integrated into a single aerodynamic assembly. German aircraft like the Heinkel He 177 bomber used similar complex wing structures, built by master craftsmen in small workshops over several weeks. At Willow Run, wings emerged from the assembly line every 35 minutes. Wiedemann observed the process carefully, noting details that challenged his understanding of aircraft construction. The workforce consisted primarily of young men and women with no aviation background, factory workers, transferred from automobile plants, farm laborers seeking industrial employment, housewives supplementing family income. Most had received only 3 weeks of training before beginning production work. This contradicted German manufacturing philosophy, which emphasized years-long apprenticeships and master craftsman certification. Thompson explained Ford's approach: break complex assembly into simple, repetitive tasks, requiring minimal training. Design specialized jigs and fixtures that guarantee precision regardless of worker skill. Create standardized procedures documented in detailed manuals. Reduce each job to its essential components, then train workers to perform those specific tasks perfectly. The system worked with automobile production. A Model T required only basic motor skills to assemble. But applying it to 4-engine bombers seemed impossible. Yet the evidence rolled past on conveyor systems, wing after wing, each structurally identical, each meeting Army Air Force's specifications. Stolper examined a completed wing assembly, checking rivet patterns, surface finish, and control linkage precision. His technical training confirmed what his instincts denied. The quality matched hand-built German standards despite being produced by assembly line workers. The fuselage section provided even greater contrast with German methods. B-24 fuselages consisted of multiple sections: nose, forward bomb bay, crew compartment, aft bomb bay, tail manufactured separately, then joined during final assembly. At Willow Run, each section moved through specialized stations where workers installed wiring harnesses, hydraulic lines, oxygen systems, and structural components using standardized procedures. No section required individual fitting or custom fabrication. Everything matched precisely because Ford had redesigned the aircraft for mass production. German bombers like the Junkers Ju-88 used similar modular construction, but each module required skilled craftsmen to ensure proper fit during final assembly. Tolerances varied between units, necessitating custom adjustments that consumed time and labor. Wiedemann questioned Thompson about quality control. How could assembly line methods guarantee structural integrity and combat readiness? Thompson led them to an inspection station where Army Air Forces officers supervised testing. Every bomber received complete systems checks, engine runs, and structural inspections before acceptance. Rejection rates currently ran below 3%, compared to 15% during the plant's first year of operation. Most rejections involved minor issues corrected within hours. Engine installation demonstrated the Industrial Revolution most dramatically. B-24 bombers used 4 Pratt & Whitney R1830 radial engines, each weighing over 1,400 pounds and containing thousands of precision components. German practice involved skilled mechanics, spending days fitting engines to individual aircraft, adjusting mounting points, connecting control linkages, and testing systems. At Willow Run, specialized crews installed all 4 engines in 45 minutes using standardized mounting cradles and pre-assembled control systems. Wiedemann watched 3 installation teams working simultaneously on adjacent aircraft. Each team moved with choreographed precision, releasing engine from overhead crane, positioning mounting cradle, securing attachment bolts, connecting fuel lines, installing cowling panels. No custom fitting, no trial and error adjustment, no individual craftsman expertise. Just standardized procedures performed by workers who 6 months earlier had been installing automobile engines on different assembly lines. The system's efficiency derived from obsessive standardization. Ford engineers had redesigned the B-24's engine mounts to accept only one installation configuration. Fuel lines, hydraulic connections, and control linkages used standardized fittings that workers could attach without measuring or adjusting. Quality control consisted of visual inspection and standardized testing. If the engine mounted correctly and passed system checks, it met specifications. Stolper requested permission to examine one of the mounting cradles being prepared for the next aircraft. The device was a masterpiece of industrial engineering, a precisely machined steel frame that positioned the engine at exact angles and held it stable during installation. In German workshops, skilled mechanics used measuring instruments, spirit levels, and careful adjustment to achieve proper engine alignment. At Willow Run, the cradle guaranteed correct positioning automatically. Workers simply placed the engine in the cradle, lifted everything into position using overhead cranes, and secured the mounting bolts. The engineering eliminated skill requirements through mechanical precision. Thompson explained that Ford had invested heavily in specialized tooling like the engine cradles. The initial development cost seemed high, but the tooling paid for itself within weeks through reduced labor requirements and faster installation times. This represented American industrial philosophy. Invest substantial capital in machinery and tooling to reduce ongoing labor costs and achieve consistent quality. Germany's approach emphasized skilled labor as the primary quality control mechanism, which worked excellently but couldn't scale to American production levels. The hydraulic systems bay revealed similar manufacturing innovations. B-24 bombers required complex hydraulic networks controlling landing gear, flaps, brakes, and bomb bay doors. German aircraft used similar systems, with hydraulic lines routed individually through the airframe by skilled technicians who understood fluid dynamics and system pressure requirements. Installation required days of careful work, pressure testing, and leak detection. Willow Run's approach transformed hydraulic installation into an assembly line operation. Engineers had designed the entire system as pre-assembled modules that workers could install without understanding hydraulic theory. Main hydraulic lines came from subcontractors as complete assemblies pre-bent to correct angles, fittings already attached, pressure tested before delivery. Installation crews simply positioned the modules, connected them at standardized junction points, and performed quick check testing. The entire hydraulic system installation took 90 minutes from start to operational status. Wiedemann questioned Thompson about system reliability. Wouldn't pre-assembled hydraulic lines prove less reliable than custom-fitted installations? Thompson directed them to a testing station where Army Air Forces inspectors examined completed hydraulic systems. Every bomber underwent pressure testing at 50% above operational maximums. Failure rates had dropped below 1% after Ford refined the pre-assembly process. The standardized approach actually improved reliability by eliminating human error during installation. Custom fitting allowed mistakes, incorrectly torqued fittings, improperly routed lines, damaged components during installation. Standardized modules arrived already tested and required only correct positioning and connection. The reduction in variables improved overall quality while dramatically reducing installation time. Stolper calculated the economic implications while watching engine installation. Germany's aircraft industry relied on small, specialized workshops producing limited numbers of complex assemblies requiring skilled labor. The system maintained quality but couldn't scale efficiently. Ford's approach sacrificed craftsmanship for volume, break complex tasks into simple procedures, hire unskilled workers, train them quickly, and achieve massive throughput. The strategy worked only because American industry possessed specialized machine tools that eliminated the need for skilled handwork. He noted this observation: American industrial advantage rests not on superior workforce, but on superior capital equipment and engineering methodology. The final assembly section revealed the system's ultimate achievement: completed fuselage sections, wings, engine assemblies, tail structures, and landing gear converged on the main assembly line, where specialized teams joined everything into finished aircraft. The process took 6 hours from first section mating to wheels-down completed bomber. 6 hours. German aircraft assembly required weeks of work by experienced craftsmen. Wiedemann requested permission to observe the complete sequence. Thompson arranged for them to follow one specific aircraft, serial number 42 to 52534, through its final assembly stages. The aircraft began as 5 major components arriving simultaneously from different plant sections: forward fuselage, center section with wings attached, aft fuselage, tail assembly, and landing gear. Overhead cranes positioned each section precisely above mounting fixtures while teams prepared connection points. Assembly crews worked from detailed procedure manuals, checking off each task as completed. Structural bolts torqued to specification, electrical connections tested, hydraulic lines pressure checked, control surfaces range tested. The bomber came together like a giant mechanical puzzle, each piece fitting perfectly because Ford's engineers had designed it that way. Within 3 hours, the aircraft was structurally complete. Electrical systems received power-on testing radios, navigation equipment, bomb release mechanisms, turret controls. Hydraulic systems were pressurized and cycle-tested. Control surfaces moved through full range of motion while inspectors verified proper response. The aircraft never left the assembly line during these tests. Everything was checked in place using standardized procedures and specialized testing equipment. After 6 hours, serial number 42 to 52534 rolled off the assembly line under its own power. Army Air Force's acceptance officers performed final inspection, signed delivery documents, and authorized the bomber for flight testing. The aircraft would spend 2 more days undergoing complete flight testing before delivery to operational squadrons, but the manufacturing process was complete. Thompson provided final statistics as they walked back toward the administration building. Willow Run currently employed 42,000 workers operating across 3 daily shifts. The plant consumed 1,100 tons of aluminum monthly, received components from over 850 subcontractors nationwide, and operated specialized machine tools numbering in the thousands. Monthly production had reached 450 B-24 bombers in August 1943 and would increase to 500 by year's end. Annual capacity would exceed 5,000 aircraft, more heavy bombers than Germany's entire aviation industry produced across all types. Wiedemann requested clarification on one crucial detail: workforce composition. Thompson confirmed that 70% of Willow Run workers had no aviation manufacturing experience before hiring. Most received 3 to 4 weeks of training before beginning production work. The plant hired continuously to replace workers leaving for military service or other employment, yet production rates continued increasing. This represented the fundamental difference between American and German manufacturing philosophy. Germany relied on skilled craftsmen, requiring years of training and apprenticeship. America relied on specialized machinery and engineering systems that allowed rapid workforce training and high turnover without production impact. The training facilities occupied an entire wing of the administration complex, with classrooms, workshops, and practice stations where new workers learned their specific tasks before joining production lines. Thompson offered to demonstrate the training process, leading them to a classroom where 20 new employees were receiving instruction on rivet installation procedures. The instructor, a young woman named Dorothy Chen, who had been a high school teacher before joining Ford, explained the training methodology. New workers received general orientation covering plant safety, quality standards, and basic procedures during their first 3 days. Then they moved to specialized training for their assigned task, in this case, installing rivets on fuselage skin panels. The training focused entirely on practical skills. Students learned to identify correct rivet types, position the pneumatic rivet gun properly, apply appropriate pressure, and verify installation quality. No instruction covered aircraft design theory, structural engineering principles, or aviation manufacturing traditions. Workers needed to perform one specific task correctly, and training addressed only that requirement. Chen demonstrated the rivet installation procedure, then supervised as students practiced on sample panels. Each student completed 50 practice rivets under observation, receiving immediate correction if they made errors. After successfully installing 100 rivets meeting quality standards, students qualified for production work. The entire training process took 6 hours. Stolper compared this with German aircraft worker training, which required months of instruction covering material properties, structural theory, quality standards, and various related skills. German apprentices learned aircraft construction as a comprehensive craft, requiring understanding of underlying principles. American workers learned specific tasks through repetition until they achieved consistent results without understanding broader context. The American approach seemed to sacrifice skill depth for training speed, but in practice, the specialized focus produced workers who performed their assigned tasks as well as or better than broadly trained craftsmen. The training facility included specialized simulators for complex tasks. One station replicated the B-24 electrical system, allowing workers to practice installing wiring harnesses without consuming actual aircraft components. Another simulated hydraulic line installation, teaching proper connection techniques using reusable training equipment. These simulators allowed workers to make mistakes and learn correct procedures without risking expensive materials or aircraft quality. German training relied heavily on apprentices working under master craftsman supervision, learning through observation and guided practice on actual production work. This ensured high skill levels but required years to develop fully qualified workers. American simulation-based training produced workers ready for production within weeks, though their skills were narrowly specialized rather than broadly applicable. Thompson explained that Ford had invested over $1 million in training facilities and programs. The expenditure seemed excessive to German observers accustomed to apprenticeship systems requiring minimal capital investment. But the American approach reduced the time required to create productive workers from years to weeks, allowing rapid workforce expansion necessary for mass production. The training investment paid for itself within months through improved production capacity. Wiedemann noted a particular detail that highlighted the philosophical difference. German aircraft workers took pride in their comprehensive understanding of aircraft construction and their ability to solve unexpected problems through skill and experience. American workers received detailed procedure manuals and were trained to follow those procedures exactly without deviation. If unexpected problems arose, specialized troubleshooters, the only workers requiring broad knowledge, diagnosed issues, and updated procedures. The system separated thinking from doing, concentrating expertise in a small number of engineers and supervisors, while the majority of workers executed standardized tasks. This approach troubled both German observers from a cultural standpoint. European industrial tradition valued craftsmanship, individual skill, and worker pride in comprehensive understanding of their trade. The American system treated workers as interchangeable components, performing repetitive tasks without understanding the larger product. Yet, the results proved undeniable. Willow Run's production rates exceeded anything German craftsmanship could achieve. The uncomfortable conclusion was that mass production required abandoning traditional notions of skilled labor in favor of specialized, narrowly trained workers guided by engineering systems rather than personal expertise. The visit concluded with a brief meeting in Thompson's office, where he answered technical questions and provided additional documentation. Stolper asked about the plant's construction timeline. Thompson explained that groundbreaking occurred April 18, 1941, with first bomber delivery in September 1942, 18 months from empty farmland to operational aircraft production. The construction schedule alone demonstrated American industrial capability that Germany couldn't match. Wiedemann's final question addressed production sustainability. Could Willow Run maintain current output levels while expanding capacity? Thompson assured him that no production constraints existed. Raw material supplies remained abundant, the workforce pool seemed inexhaustible, and machine tool manufacturers could provide additional equipment if needed. The only limitation was physical facility space, which could be expanded if required. The two German officers departed Willow Run late afternoon September 4th, carrying notebooks filled with observations, calculations, and technical details. Their official report would require careful composition. Berlin expected analysis, not defeatism, but both men understood what they had witnessed. American industry operated on a scale that made direct military comparison meaningless. The flight back to Washington gave Wiedemann and Stolper time to process their observations and begin drafting preliminary assessments. Neither man spoke during the first hour, both absorbed in reviewing notes and recalculating figures that seemed impossible despite being documented and verified. Stolper broke the silence first. We have based strategic planning on fundamentally incorrect assumptions about American industrial capability. The statement required no response. The evidence spoke clearly. German intelligence had assessed American manufacturing capacity based on peacetime production data and Great War performance. Those calculations showed the United States possessed substantial raw material resources and large workforce, but lacked the engineering precision, skilled labor, and manufacturing discipline necessary for complex military equipment. The assessment concluded that American industry could produce large quantities of basic equipment, trucks, ammunition, rations, but would struggle with technically sophisticated weapons like aircraft, tanks, and naval vessels. Willow Run demolished that conclusion. Ford had taken the most complex American bomber design and transformed it into an assembly line product manufactured by largely unskilled workers at rates exceeding Germany's entire aviation industry. Wiedemann calculated the strategic implications systematically. If one American automobile company operating a single plant could produce 450 heavy bombers monthly, what could the entire American industrial base achieve? Ford operated 4 other major manufacturing complexes. General Motors possessed even greater production capacity. Chrysler, Boeing, Douglas, Lockheed, and dozens of other manufacturers contributed to war production. The United States had essentially converted its entire peacetime economy, the world's largest, into military manufacturing, while maintaining adequate civilian production. Germany possessed nothing comparable. The Reich's industrial base operated near maximum capacity, producing approximately 15,000 aircraft annually across all types. American production already exceeded 40,000 aircraft per year and continued expanding. The gap would only widen as American industry reached full mobilization. Stolper approached the problem from economic perspective. Germany's war economy depended on conquered territories for raw materials, slave labor for manufacturing, and careful allocation of scarce resources. American manufacturing operated without such constraints. Rubber, aluminum, steel, and other strategic materials flowed into factories in unlimited quantities. The workforce expanded continuously through migration from rural areas and increased female participation. No strategic bombing threatened production, no partisan attacks disrupted transportation, no resource shortages limited output. The comparison extended to specific materials that highlighted the imbalance. Aluminum production provided the clearest example. B-24 bombers required approximately 12 tons of aluminum per aircraft. Willow Run's monthly production of 450 bombers consumed 5,400 tons of aluminum just for one plant, building one aircraft type. American aluminum production in 1943 exceeded 920,000 tons annually, with capacity expanding steadily. Germany's aluminum production reached only 243,000 tons in 1943, despite using every available bauxite source in occupied territories. The 4-to-1 advantage in aluminum alone made matching American aircraft production mathematically impossible. Steel production showed similar disparities. The United States produced 89 million tons of steel in 1943, while Germany managed 34 million tons. American steel production operated without significant constraints. Ore arrived from Minnesota's Mesabi Range via Great Lakes shipping, coal came from Pennsylvania and West Virginia, and manufacturing facilities operated immune from strategic bombing. German steel production faced constant pressure from Allied air attacks, transportation difficulties, and raw material shortages as occupied territories became less reliable. Copper, critical for electrical systems and ammunition, demonstrated even more extreme imbalance. American copper production exceeded 900,000 tons annually, supplemented by imports from South American sources. Germany struggled to produce 80,000 tons while rationing copper carefully across military and industrial needs. The tenfold advantage meant American electrical systems could use copper generously, while German engineers designed equipment around copper scarcity. The petroleum situation proved most critical. American oil production exceeded 1.5 billion barrels annually, making the United States the world's dominant petroleum source. Synthetic fuel plants, refineries, and distribution networks operated without disruption. German oil production from Romanian fields and synthetic fuel plants totaled perhaps 10 million tons annually, barely sufficient for military requirements and vulnerable to Allied bombing. This gap affected every aspect of military operations. American forces trained extensively using abundant fuel supplies. German pilots received minimal flight training due to fuel rationing. American mechanized units operated without fuel constraints. German panzer divisions carefully rationed fuel for every movement. The petroleum imbalance alone would decide the war's outcome regardless of other factors. Labor resources presented another fundamental asymmetry. The United States maintained a civilian workforce of over 65 million people in 1943, while fielding military forces exceeding 11 million personnel. The workforce included substantial female participation. Women comprised 30% of Willow Run's employees and could expand further through increased female employment and agricultural mechanization. Germany's workforce suffered constant depletion through military casualties and couldn't be expanded significantly. The Reich relied increasingly on slave labor from conquered territories, which proved less productive than free workers and created additional security costs. American abundance of labor, materials, and capital created a self-reinforcing advantage. Factories could operate multiple shifts, expand capacity continuously, and waste resources during learning processes without strategic impact. Germany's resource constraints meant every decision involved trade-offs. Aluminum, used for aircraft, couldn't be used for other purposes. Workers assigned to tank production weren't available for other industries. Copper allocated to ammunition production wasn't available for electrical systems. The fundamental imbalance became clear. Germany fought a war of scarcity while America fought a war of abundance. Every German tank, aircraft, or ship represented scarce resources carefully allocated. Every American vehicle, plane, or vessel was one of thousands produced continuously without resource constraints. Attrition warfare, the strategy Germany had adopted after failing to achieve quick victory, could not succeed against an opponent capable of replacing losses faster than they could be inflicted. Wiedemann drafted the first section of their report during the flight. American war production operates on industrial principles fundamentally different from European manufacturing tradition. The emphasis on standardization, specialized machinery, and rapid workforce training allows unprecedented production volumes with minimal skilled labor requirements. Ford Motor Company's Willow Run facility demonstrates these principles applied to complex aircraft manufacturing. Current output of 450 B-24 heavy bombers monthly from a single plant suggests total American aviation production capacity exceeds previous German intelligence estimates by factor of 3 to 5, Stolper added. His economic assessment. The American industrial mobilization occurs without apparent strain on civilian economy or resource allocation conflicts. Consumer goods remain available, civilian construction continues, and workforce expansion shows no evidence of approaching limits. This suggests substantial additional production capacity could be mobilized if required. Their preliminary conclusions proved difficult to articulate in formal intelligence terminology. Both men understood the fundamental message. Germany could not win a production war against the United States, yet this conclusion contradicted years of intelligence assessments, strategic planning documents, and Führer directives. Presenting such findings required careful documentation and irrefutable evidence. The notebooks contained that evidence detailed observations, production figures verified through multiple sources, technical specifications confirmed by inspection, workforce data obtained from official guides. No element of their report would rely on estimates or assumptions. Every statement would be supported by documented observation from the Willow Run visit. They reached Washington after dark September 4th, checked into their embassy quarters, and spent the night expanding their preliminary notes into a formal assessment document. The report would go through diplomatic channels to Berlin, where intelligence analysts would evaluate the findings and brief Wehrmacht planning staff. The impact would depend on whether German command accepted the assessment or dismissed it as American propaganda. Neither man felt confident about that reception. The final report, completed September 7, 1943, ran to 47 pages, including technical appendices and production calculations. The summary section laid out the key findings. Inspection of Ford Motor Company's Willow Run bomber production facility reveals American war manufacturing capability substantially exceeding previous German intelligence estimates. Single plant employing 42,000 workers, 70% without aviation manufacturing experience, produces 450 B-24 heavy bombers monthly, using assembly line methods adapted from automobile manufacturing. Production quality meets or exceeds conventional aircraft manufacturing standards despite minimal skilled labor requirements. Plant operates without apparent resource constraints, raw material shortages, or workforce limitations. Facility demonstrates industrial capacity and manufacturing methodology. Germany cannot match using conventional European production systems. Strategic implications. Total American aircraft production likely exceeds 40,000 units annually, compared to German output of approximately 15,000 units across all types. This production differential, combined with American raw material abundance and intact industrial infrastructure, suggests long-term military outcome will favor United States regardless of tactical battlefield success. The diplomatic pouch containing Wiedemann and Stolper's report departed Washington September 10th, traveling through neutral Portugal to Berlin. Intelligence analysts at Luftwaffe headquarters received the document September 24th and circulated copies to relevant military commands. Initial reaction proved skeptical. Several senior officers questioned whether the reported production figures represented actual output or propaganda designed to demoralize German forces. Some analysts suggested the Americans had prepared an elaborate deception specifically for the German observers. Others noted that American industrial claims during the Great War had often exceeded actual performance, but supporting evidence arrived from other sources. German intelligence officers in Switzerland reported similar information from industrial journals and technical publications. Intercepted American radio broadcasts referenced Willow Run production figures matching Wiedemann's observations. Reconnaissance photographs from German agents in South America showed other American aircraft plants with similar large-scale facilities. The assessment gained credibility despite its disturbing implications. By October 1943, German military planning began incorporating revised estimates of American production capacity. Strategic assessments acknowledged that the United States would achieve overwhelming material superiority within 12 to 18 months, regardless of German countermeasures. This recognition influenced several major strategic decisions during late 1943 and early 1944. First, Germany accelerated development of advanced weapons systems, jet aircraft, rockets, new U-boat designs, hoping technological superiority might offset American quantitative advantage. The strategy showed some promise with aircraft like the Me-262 jet fighter, but development delays and resource shortages prevented these systems from affecting the war's outcome. Second, Wehrmacht planning shifted toward defensive operations, designed to maximize American casualties and delay victory rather than seeking decisive battlefield success. The assumption was that high casualties might erode American political will to continue fighting. This strategy failed to account for American replacement capacity units. Suffering heavy losses were reconstituted within weeks, using replacement personnel and equipment flowing from American factories. Third, German industrial planning attempted to adopt some American mass production techniques. Albert Speer's ministry issued directives encouraging standardization, specialized tooling, and simplified manufacturing procedures. However, Germany lacked the machine tool capacity, raw materials, and intact infrastructure necessary to implement such changes effectively. Fourth, intelligence resources shifted toward gathering technical information about American manufacturing methods, hoping to find weaknesses or limitations that could be exploited. This effort produced detailed information about American industrial operations, but revealed no significant vulnerabilities. American abundance proved difficult to counter through any strategy available to resource-constrained Germany. The strategic reality became increasingly clear throughout 1944. Germany was fighting an opponent with effectively unlimited industrial capacity. Every German tank destroyed, aircraft shot down, or ship sunk would be replaced by Allied production within days. Every German unit decimated required months to reconstitute using increasingly scarce resources. The mathematical inevitability of defeat became apparent to anyone willing to examine production statistics objectively. Wiedemann and Stolper's report remained classified during the war, but its conclusions proved accurate. American aircraft production reached 96,318 units in 1944, compared to German output of 39,807 aircraft. American aluminum production exceeded 1 million tons annually, while Germany struggled to maintain supplies above 200,000 tons. American factories operated without significant bombing damage, transportation disruption, or resource constraints, while German industry faced constant Allied air attacks, raw material shortages, and labor difficulties. The production differential translated directly into military capability. By June 1944, the 8th Air Force alone operated over 2,000 heavy bombers, supported by thousands of fighters. The Luftwaffe could muster fewer than 300 fighters to oppose D-Day invasion forces. American ground forces advanced using thousands of tanks, trucks, and artillery pieces, replaced immediately when lost. German panzer divisions fought with equipment that couldn't be replaced once destroyed. Naval superiority became overwhelming. American shipyards launched escort carriers, destroyers, and landing ships faster than U-boats could sink them. The industrial imbalance manifested most dramatically in casualty replacement rates. American divisions suffering 50% casualties received complete replacement personnel and equipment within 2 weeks. German units took months to rebuild and often never returned to full strength. This asymmetry meant American forces could sustain offensive operations continuously, while German forces weakened progressively through attrition. The strategic outcome that Wiedemann and Stolper recognized at Willow Run became reality by mid-1945. Germany's military forces, despite tactical skill and technological innovation, could not overcome the industrial superiority of an opponent producing war material in virtually unlimited quantities. The war's conclusion was determined not primarily by battlefield performance, but by manufacturing capacity, precisely the imbalance the two German intelligence officers had documented during their September 1943 visit to a single American factory. Post-war analysis confirmed the accuracy of Wiedemann and Stolper's assessment. American war production totaled approximately 300,000 aircraft, 88,000 tanks, 3,000 naval vessels, and millions of trucks, artillery pieces, and other military equipment. German production, despite operating at maximum capacity and using slave labor, reached approximately 90,000 aircraft, 25,000 tanks, and several hundred major naval vessels. The quantitative gap, roughly 3-to-1 in most categories, proved decisive. Allied forces enjoyed numerical superiority in every engagement, could afford high casualty rates knowing replacements would arrive immediately, and steadily ground down Axis forces through sustained attrition. German attempts to counter American industrial superiority through advanced technology, tactical innovation, or strategic brilliance proved insufficient. The Me-262 jet fighter demonstrated technical superiority over American piston-engine aircraft, but appeared too late and in too few numbers to affect outcomes. Advanced U-boats with improved capabilities faced overwhelming Allied anti-submarine forces, supported by unlimited replacement capacity. New tank designs like the Panther and Tiger outperformed most Allied armor but couldn't be produced in sufficient quantities to matter strategically. The September 1943 visit to Willow Run represented the moment when German intelligence fully understood the industrial imbalance that would determine the war's outcome. The two officers who witnessed Ford's assembly lines understood immediately that Germany faced an opponent whose manufacturing capacity made conventional military victory impossible. Their report documented this reality in precise detail, supported by verified observations and technical data that could not be disputed. German military leadership received this assessment and understood its implications. Strategic planning after late 1943 focused increasingly on delaying defeat rather than achieving victory. Resources flowed toward advanced weapons that might provide temporary tactical advantages, defensive strategies aimed to maximize Allied casualties and buy time for political settlements. But no strategy could overcome the fundamental imbalance of industrial capacity. The day Wiedemann and Stolper watched B-24 fuselages roll past at Willow Run, they witnessed the mechanism that would ultimately defeat Germany, not superior tactics, technology, or generalship, but simply overwhelming industrial production capacity applied systematically to military manufacturing. The historical lesson proved enduring. Modern warfare depends ultimately on industrial capacity rather than military tradition, tactical brilliance, or technological innovation. Germany possessed superior military tradition, excellent tactical commanders, and significant technological advantages in several weapons categories. But these advantages meant nothing against an opponent who could produce replacement equipment faster than it could be destroyed. The United States transformed its vast peacetime industrial economy into military production without significant civilian hardship, resource constraints, or capacity limitations. Ford's Willow Run facility, a single plant operated by one automobile manufacturer, produced more heavy bombers annually than Germany's entire aviation industry. That reality, more than any battlefield outcome, determined the war's conclusion. The two German intelligence officers who observed this industrial revolution understood its implications immediately. Their report documented what German military leaders gradually came to accept. The war's outcome would be decided by production capacity, and in that competition, Germany had already lost. Today, the Willow Run facility no longer produces bombers. The massive assembly building was partially demolished after the war, though portions remain preserved as historical sites. The B-24 Liberators manufactured there served throughout World War II in every theatre of operations, flying over 200,000 combat sorties and delivering more than 635,000 tons of bombs. Over 18,400 B-24 seconds were produced during the war, 8,685 of them at Willow Run. The aircraft represented American industrial capacity translated directly into military power. The story of Wiedemann and Stolper's visit remained classified for decades after the war. Their report, declassified in the 1970s, provides remarkable insight into how German intelligence assessed Allied capabilities during the war's critical middle years. The document's accuracy proved extraordinary American production reached and exceeded even their most pessimistic projections. Their conclusion, that Germany could not win a production war against American industry, was correct. But that conclusion, delivered to German command in September 1943, arrived too late to change strategic decisions that had already committed Germany to a war it could not win. The fundamental lesson endures. Industrial capacity determines modern warfare outcomes more than any other single factor. Military forces require constant resupply of equipment, ammunition, fuel, and replacements. Nations capable of providing unlimited material support can sustain operations indefinitely and absorb casualties that would cripple opponents with limited production capacity. America's ability to convert its massive peacetime economy into war production without suffering bombing damage or resource constraints provided an insurmountable advantage. The September 4, 1943, visit to Willow Run revealed this reality to German intelligence observers who understood immediately what it meant for the war's outcome. Their report documented the moment when German strategic planning confronted the mathematical certainty of industrial defeat. The assembly lines they observed that day, producing bomber after bomber in a facility that dwarfed anything Germany could build, represented the true weapon that would win the war. Not superior tactics, not better technology, not more skilled troops, just overwhelming industrial production capacity that could not be matched, countered, or overcome by any strategy available to resource-limited opponents. The story of the day German spies visited Ford and realized the war was lost demonstrates how warfare had changed fundamentally by the mid-20th century. Victory no longer depended primarily on battlefield performance, but on industrial capacity to sustain military operations indefinitely. The two intelligence officers who watched B-24 bombers roll off Willow Run's assembly lines understood this new reality immediately. Their report to Berlin documented the industrial imbalance that would ultimately determine the war's outcome. Today, historians recognize their assessment as one of the most accurate intelligence evaluations of World War II, a clear-eyed recognition that American industrial superiority made German military success impossible, regardless of tactical, battlefield performance. The war's conclusion was written in the production figures they recorded that September afternoon in Michigan, as one bomber after another emerged from assembly lines that had no equivalent anywhere in Germany. That moment, standing in Ford's massive factory, watching industrial processes that German manufacturing could not replicate, marked the point when informed observers understood the war's inevitable outcome. The battlefield fighting would continue for another 20 months, millions more would die, and tremendous destruction would occur. But the strategic result had already been determined by the industrial capacity they witnessed that day, a reality both men recognized immediately and documented precisely in their report to Berlin. What is your perspective on this part of history? Share your thoughts in the comments because every memory and reflection helps keep the past alive.